let's get started. And I upload another PowerPoint. Last time it's called BN. This time I call it BN Plus. Basically, I add a little more to what I did. And I also show some of the also show some of the homework, what I'm talking about, okay? And I'll let you see it and know how to, everybody should be able to do it, but I would also like you to think hard that for those of you looking for a job in data mining, machine learning, something deeper than just, looking at a graph, I'll say that you could make the homework even harder yourself. But I'll show you what I'm really looking for. What do I mean by adding a shape or adding a cloud to make things easy to understand? And basically it's the following, okay? At the end, I'm just, saying, okay, if this area is blocked in one color, this area is blocked in a different color, so you basically said, okay, which area I'm considered as myself, as a, so I have this purple area, and then the red area become the ancestor conditionally independent. I'll coming back for detail, okay? So, or your homework problem at the end is I'm asking you to do the same thing. Okay, I want to know something, and then if I block something, then the rest will be independent or dependent or the stuff. So for you is, I already give you the answer. You just need to block them and then figure out why blocking them then become conditionally independent or dependent to be de-separated. That was the, I want to talk about C and E, why I block here and here. Then suddenly this two blue, which is my C and E. Basically, cannot get any more information anywhere else. That's it, okay? And if I'm teaching this, usually I'll repeat this by definition in day one. Information is to reduce uncertainty. So you want to try to reduce your probability to a smaller number. Or increase your probability of success. Or increase your probability of your judgment. So reduce the uncertainty means what kind of information can I use to do that? Okay, since this is not really my class, I won't tell you how to calculate that information in bits. But in this class, you're just thinking about, I make the probability of something increased. That was the case. That is the case. And by the way, everybody said that the mics, seems like the portable mics is not working. So I need to, for the online student, kind of like repeat a little bit of what we did last time. That's why I changed the PowerPoint a little bit. So you're not going to be bored about this whole things. Okay? And several things I need to talk about. First thing is, we already explained last time, okay? Whenever I have I can use this one, okay? If I have something I consider is independent, like, someone in a toxic environment and someone is smoking, and some people are smoking and in a toxic environment, okay? So here, this should be T, not E. Environment is toxic, okay? And here should be exposure to toxic environment. So look at here. By definitions, probability of smoking is 40 out of 100. So 4 over 10, right? Or 40 out of 100. And in a toxic environment, I have 3 columns, so that's that. And then what is probability of smoking and toxic is 12. And you know that PST equal to PT times PS. So that is the definition of independent. Agree? And all we care about is that, okay, am I talking about this? Okay? In a very, very big context. Remember the hot and sour soup things? Or it's just basically said that, oh, can I frame a cage? Within that cage, make them independent. Or later on, I'm going to do it the opposite way. Is that, can I frame a set? In that set, I can make, well, I can talk about it right now, just for a second. So I have a toxic, I have a smoking. And then look at here. I can have the cancer, which is red. So how many red smokes? 10 of them smoke out of 17, right? I have 17 red. I have, given the red cancer, how many toxic is this many, right? So that's what? 8 over 17, right? Right? So what's the next one? Is if I ask someone who has cancer, also smoking, who has cancer and also smoking is this many. But given that C and S and are in a toxic environment is 4 out of 10. Follow me? Can you see that? So obviously you can tell by asking, provide extra, smoking and cancer, and this probability dropped. That means what? That means that by providing that extra smoking information can change the equations somewhat. And we would like to know, so in this case is from what? From independent to conditionally dependent. Would you agree with me? Because this frame is not a perfect frame. If this frame is, is like this, then within that red, if these 3 are red, okay? If these 3 are red, then no matter what, frame or without that frame, it's gonna be independent all the way, agree? Because you're gonna have this many and this many. You follow me? But that's not the case. And I would say that to understand Bayesian network, this kind of frame is the key. Frame means that asking extra questions. Okay? And now let's go back to the basic. Okay? I already explained to you of these separations. Okay, X and V, let's just look at this 3. X and V, okay? X and V should be independent, agree? Because anybody got any common ancestor of X or common ancestor of V? No. But so X and V are unconditionally independent. Second, X and V are dependent if I have the information about you. So I can have smoking in a toxic environment. They supposed to be independent. But if I'm in a cancer unit, given that I'm talking about a cancer outcome, then they're not equal. Okay? So as long as I can say something about this, the outcome U become a frame to make the XUV insert XUV becomes conditionally dependent. Oh, by the way, when you do stuff like this, okay, all you care about, there's another way you can look at this, is using Venn diagram. And I can do it this way. Just for one second. You can have 3 shape. Okay, this is my X. Following shape and fill 80. Okay. Here. If I'm talking about, how given red is the base, how much yellow inside the red. That is given, the join part is this amber part, right? Is the amber over the red. That's the conditional of this part. But if I have the join of blue and red, what is the conditional of yellow? Is this overlapping area as the denominator, and then this 3-layer overlap is the top. You guys follow me? Show of hands, how many of you see what I'm talking about? Okay. Anybody kind of like, wiggle your finger and said, what are you talking about? You all get it? P red, P blue. In between is P red and blue. And given that P red and blue, I said that I would like to know yellow. So it's what is P yellow given red and blue? Is this tiny area over that overlapping area. Okay? So what I'm saying is that to me, Venn diagram is a good way when you get confused to kind of look at it that way. Okay? And don't treat Bayesian network like some magic language. It's just no big deal. Just a bunch of accounting process. Okay? So back to the equations. D separation, all you have to do in this case is already x, y, okay, are independent. Okay, now let's go to the next one. So x coming down, y coming down, v coming down to u and w. So v and x share the same child. V and w share a same child. Okay? So next, U and W. U and W, are they unconditionally dependent? U and W, are they unconditionally dependent? Are they dependent? Why? Because in experimental design, they have a confounding factor V, right? Remember last time I talked about this? Two students. They're from different country, different everything's. Originally, they're independent, but somehow they sit in my class, influenced by me. So their judgment about something now suddenly got a piece of what Simon said. So V is considered the confounding factor causing them to be unconditionally dependent. Okay? And finally, U and W, okay? U and W are conditionally independent if I can take the information V out. So given V, okay? Given V, this part is typical the hot and sour soup example, right? Once I have they become conditionally independent. If you frame the problem right, why is conditionally independent? Because people like hot, people like sour, who knows? They have all kinds of overlapping. But if I frame it right? I said, oh, they are like Indian food. So now inside that, given Indian food hot, given Indian food sour, become hot and sour, given Indian food equal to probability of hot given Indian times probability sour given Indian. And so this is the statement. U and W given V become PU over V and PW over V. This is exactly what I did at the beginning, okay? And then X and Y are unconditionally independent. Why? Because they don't have a common ancestor. They don't have a grandpa or dad on their top. X and Y are not conditionally independent, okay? Given U and W. Because given U and W, okay? Given U and W, PXY given U and W is not equal to PUW given X and PUW given Y. Why? Because U and W, they have a common influence from B. Okay, now I'm going to talk about this. This is a very famous example from the cancer study. Okay, age and gender. Usually, when we talk about, strange. Usually, when we talk about age and gender, in this classroom, I randomly select a female male student or ask you about your age. I can first ask, I first said, oh, I'm going to pick people 25 to 30. I can randomly pick that. And then pick the age, pick the gender. So do age first and then pick gender within age. Or I can pick gender first and then once I pick the gender and then pick age. The probability of these two things should be what? Independent, right? How old are you and what gender are you is beyond any control. Okay, so we know that because of that, PAG equal to PG times PA. And then, if that's the case, means what? Asking you about your gender, given I already know the probability of your age, is, by knowing your gender, not going to provide me, here, by asking you how old are you, let me put it this way. I said, hey, how old are you? Are you 30 years old? There's a probability that you're 30 years old, right? Okay? By guessing you're 30 years old, does that change because of I know your gender? No. And vice versa. By knowing your gender, the PG given A, provide that extra information about A, doesn't help me reduce the, because they are independent. Okay? And so, such that the Bayesian rule, the chain rule, apply. Next, okay? However, okay, if I know that this is a common ancestor one, the experimental design confounding factor, okay, given that I know you have this serum calcium and lung tumor, serum calcium I think is your X-ray going to show it turned white, means that it's calcified or there's some problem. Okay, so we know that serum calcium and lung tumor usually they're highly dependent. Okay, however, okay, if I know the cancer information, I can pull that cancer information out. Then serum, this one is independent given I know cancer, or this one is independent of this given cancer. So now the independent is by, here what we're saying independent is by just doing this, right? Providing extra is no use. Now, providing extra is no use by saying, oh, if I know serum is no use, because I already have a frame of C already involved. You guys follow me? Because here, this one I don't need to anything extra. I don't need to say, oh, if I have here is given you, oh, your UNCC students, given your UNCC students, then the statement PAG, PA given G and UNCC become PA given UNCC, then I know it's conditionally. But now, this is basically said that given C, now this SC doesn't provide you that information. This is conditionally independent. Okay, more, okay, exposure of toxic. Okay, so I'm talking about effect and cause. Exposure of toxic and exposure of smoking, then both can cause cancer. Okay, and so exposure of toxic and you smoke or not smoke, independent, right? But if I framed it and said that given I know if it's cancer, you have cancer or not cancer, then these things become not independent. And in this case is this probability greater than this probability. And how did I do that? That's the example I just showed you. I made up this just an hour ago, right before the class. Okay? Here, people, originally toxic or smoking, independent, agree? But now, by framing inside red, okay, they are not equal. Actually, one is greater than the other. And why that happened is simply because your frame is not orthogonal, okay? I shouldn't use that term, but orthogonal in experimental design is independent in probability statement. And another way to here, if I have something, okay, you want to calculate the area is what? X increase, Y increase. Here, let me give you one simple example. X and Y. Okay. And if, okay, this is a perfect line. Okay, this is 1 equal to this is plus 1. And this is 3 times X. Okay, and Control C, Control V, okay? And now Control C, Control V. You guys, you know that Y is proportionally increased with X, right? Right? So when X increase, Y increase, X times Y, the area between X and Y increase, right? So the covariance of X and Y will be what? It's just, you know, how big, because it is X minus X bar times Y minus Y bar. So this thing is basically, here, let me just plot it. Here. Here, X and Y in the second dot, the area is this much. X increase, Y increase, the area increase gradually. So the covariance of this whole things, the correlation of this things equal to 1. The covariance just keep growing with the scale. So whenever your area is proportional to each other, you know that the area is orthogonal. X and Y are orthogonal. And probability-wise, you're going to see it's things like this. It's the count. Okay? Imagine this, okay? I have a bunch of coins in my hand. Okay? A bunch of penny in my hand. I throw those penny on the table. That will be a vector. So all the coins if I have a coordinate of X and Y on the table, then those coins gonna form a very, very narrow straight line, agree? So if you look from the top, X and Y of those coin positions are highly correlated because they are generated from a magic hand, my force, causing the X and Y spread the same way. But if you look at sideways, the stacks of those coins, increase, increase, increase. There are a lot of coins increase the same way. So you look at sideways, looking at a histogram, you know that they are independent. Okay, so, no, they are dependent because they're also framed by the same force. Okay, and I'm just trying to tell you that orthogonal concept in experimental design and the probability statement here are highly correlated, okay, associated. Okay, so everybody agree with me? This statement, okay, originally, these two things, exposure and smoking, are independent. But even if I frame them, given cancer, they become dependent. This numerical example shows that. Agree? Agree? Originally, already here. Here, originally, how many toxic, probability-wise, and how many smoking, and how many joint smoking and probability, this thing is independent. Agree? But once I frame the questions inside the red, this becomes conditionally dependent on the cancer question I ask. Okay? So now let's go back to this. Okay? Then conditionally independent becomes cancer is independent of age and gender given smoking. So what really, I don't care what age or what gender you have. If you smoke, you're more likely to have cancer. So if I know you're smoking, okay, then you will have cancer. The probability is not changing because I know your age or your gender. So we can say that cancer is orthogonal of age and gender given I know this is a smoker. Okay? Now we can turn the problem, become conditional independent with all this. Okay? Yeah, I know this. Okay? Some people, when they get older, they are more likely to have exposure to toxic because their work, or they are more likely to smoke. And then gender influence, usually, well, at least I think in Asia, male smoker more than female smoker, but not in some European country. I actually see more female smoker. Okay? And just like I see, usually think surgeons or doctors, they don't smoke. Wrong. If you go to the back of any major hospital, sometimes you see a lot of smoker wearing white coats. Okay? But here we're saying that age influences this, and gender influences this, and then both can cause cancer. Okay? And then, so when I say that you use a shape cloud to cover this, it's basically ask you to do this. Where's insert shape? Oh, here we go. Okay? I'm basically just saying that whatever the graph you're looking at, you can say that I'm going to block this. And when you block them, you can consider that I'm blocking myself, looking things up. Are they converge from different source? Or they diverge to different source? So in this case, you can just block layer by layer. But first, there will be a root cause or root, age and gender that are non-descendant. And then there are the parents, okay? Age to smoking, gender to smoking, and then those cause cancer. And then if you have cancer, then there should be some lab outcome showing certain things, your X-ray or not X-ray, your certain imaging techniques are going to show you have a tumor. So I would like you to just using the way to block this whole things. And why you need to do that? Because if you do that, okay, then you know this. If I add, say originally I have this whole things, right? I can treat this whole thing as one block, one big blob, and all I know is that this big blue block influence my diet, but also influence this. So cancer is independent, okay, of diet, given I know the exposure and smoking. Why is that? White, red can be considered independent. Cancer is independent of diet, given exposure and toxic. Intuitively, do you think diet can influence you going to have cancer or no cancer? Not in this case, right? Lung cancer is more from respiratory problem, right? Smoking related to your lung, right? And here what we're trying to show is this, okay? If I know you have this and this, by knowing your diet, does that influence the probability of you going to have cancer or no cancer? Adding the PD into the picture going to change the probability estimation of you're going to have cancer or no cancer? No, because it's independent from everything, right? Why? Because there's another way, I think in the books, they talk about Marco blanket many times. Anybody can tell me why it's called Marco blanket? Okay. Anybody know what is Marco conditions? How many of you have Marco chain before? Okay, in Marco chain, okay, and say A hit B, B hit C, C hit D, A, B, C, D in a chain. Okay, so there are a chain of event. So I am Z, I'm at Z. Okay, do I really need to know A, B, C, D, E, F, G, all the way to X, Y to figure out Z? Or all I need to know is, like, what is the probability previously at Y? Marco Chen basically said that, hey, don't look all the way. All the information you need is carried by your previous node. So here we basically said that, what should be considered as your previous node? Of course, for cancer, okay, everything can be considered as a previous node is this big blue blob, right? By knowing that big blue, everything else, age influence, gender influence, all that information is carried by that big blue. You agree with me? So that's why they call it Marco blanket. It's, everything you want to know, it's kind of like chaining, right? A push B, B push C. I don't care how you push it. As long as that I'm at Z. And all I ask is that who is pushing me? And say, Y is pushing you. So all I need to know is the probability at Y. What do you have at Y? And then I can figure out all the yada yada stuff is already, yeah?
My age and gender were also a part of the group job.
What?
What if age
Well, yeah, you can consider that. But what I'm saying is that, That's actually what I did last time. I said that you can consider that there's a big blue block causing cancer. But then we have to do this. Okay, now let me focus within the big blue. And within the big blue, I need to say that, hey, what's inside the big blue? Oh, there are some yada yada within the big blue. So I need to say, and what's that yada yada within the big blue? And I basically say, don't look anything else, just focusing on the purple, and purple is causing by the pink. Would you agree with me? So it's kind of like, okay, you can consider that there's a whole story. But for me, all I care about is that if I treat this whole thing as a whole story, but within the whole story, there are story inside a story. So in other words, is that can I have a Marco blanket inside a Marco blanket? Can I? Can I have a Marco blanket inside a Marco blanket inside a Marco blanket? So while you're trying to build this blanket, you basically try to say, if you do it right, you can use few blanket, cover everything. So it's kind of like dissect this complex structure. You follow me? But if you don't know how to do let me put it this way. What will be a system engineer or any information science nightmare? I need to evaluate node by node, right? So if I can find a way to organize them and say, first chop this, understand, ask the question here, and then I can separate. Ask the question here, I can separate. I can dissect this very, very quickly. And how many of you have a nice turkey dinner during the Thanksgiving? Yeah, okay. How many of you ever carve a, 10-pound-ish huge turkey? Carving turkey is art. If you don't know how to do it, it's very, very messy because turkey is very, very fiberish. Okay? And so you can tell, okay, if you got invited to some Thanksgiving dinner, you know that some people, they just can dissect a turkey really, really quick and no messy. But some people, they don't do it right. Every piece is a struggle, okay? And what we're doing right now is try to dissect the turkey, okay? So by saying this, people were trying to figure out how to block them one by one, okay? And why we want to block them one by one? So we can use the chain rule. And if we use the chain rule, for example, put everything together, what is the join probability? I only need to know PA, PG, and then A influence, given A, I need to understand how it influence E, given A and G, how to influence smoking, and then after that, I need to understand how the E and S influence C. So can you see this computational things was established pretty much based on this, right? You see that? Yeah, so the computation really is dissect the graph. Okay? And then finally, given C, and this whole thing's become the joint probability of every possible conditions. And so here, I'm showing the example using computation of the diamond shape, because I have a loopy loop here, A, B, C, D, I showed last time. And then you can see that, okay, by the production rule, I need to know E, I need to know this. And then since E, all the information E needed is carried by C, so you can just reduce E given A, B, C, D become E given C. So you make it small. And P, A, B, C, D is the part still there. But then once you have the ABCD done, you basically said that, okay, now I can deal with ABC. Because if I deal with ABC, then all I need to know is that this big blob is common source. Here I have a red cloud causing D, I have a red cloud causing E. And this is the part that I'm really trying to show you, is that this graphical dissect is, or conditional independent or D separation is all trying to just do that things, okay? And so here is a numerical example: smoking, bronchitis, lung cancer, fatigue, or difficult to breathe, and X-ray confirm, the imaging confirm. So why you put an X-ray sideways here? Because now you'll not always go, you have fatigue, you have difficult to breathe, you may not go see the doctor. So X-ray is, because of you have a cancer here, so then you will confirm that, okay? So you can do the computation the same way and get the computation done by only using 1, 2, 3, 4 multiplication, rather than doing 2 by 2 by 2, 32 possible combinations. Okay, so let's talk about your homework, okay? So this is the part I was hoping you to do, is here. I'm blocking C and E, okay? Once I said C and E are the blocked, okay? Then all you need to figure out is that, hey, what really, here, for one, for this side, is there the common ancestor for this 2 blue dot? Is there a common ancestor of this 2 blue dot?
Yes.
Which one?
A.
Huh? B, right? B is a common ancestor. Done. Okay? Then here is another one, okay? Are there any common ancestor happen here for the 2 blue dot? If I consider AD is a one big block, then this big block coming down this way, right? So would you agree with me? If I control this and this guy and this guy could be separated. Yeah? So graph, it's a lot easier to understand. Okay? And let me be honest with you, this is Dr. Shu's homework. Okay? If it's my homework, it's what I will do. I'll say that fake a probability statement like this. You show me originally it's not independent, now you make it independent because of you add some information in there. Because if you can do that later on, if I introduce any softwares, you can basically say, oh, big deal. It's just hot and sour soup, nothing else. Okay? But here, would you agree with me? When you do this, you're basically trying to create that, okay, I need to make C and E independent. I need to block some stuff coming in. Okay? That is one way to block it. Anybody agree? B is no escape. You have to block it no matter what. Anybody agree with this one and say that, well, if I block D and F, also block the whole thing? Agree or disagree? Do I? Sure, you can say that, oh, I need to block all this stuff. But since we're trying to, try to do a little jobs, as little as possible, not a subset. Would you agree with me? Blocking here is already blocking whatever can come here or go there, right? Agree?
Why would blocking F
Oh, here. Well, let me ask you this. Let's say don't block F. Okay? Don't block F. Do you think the two blue dots gonna be independent? If I don't block F, can the two blue dots be independent? Look, Yami, look at the screen.
The PowerPoint right now.
Yeah. If I don't block them, can they? Can the two blue dots be independent? I'm not blocking F now.
I guess not because A.
Because A could be a common ancestor confounded the two blue dots, right?
Yeah.
So
Yeah.
when you block it, do you also block the arrows? Or are you just blocking the spot? Does that make sense? Because like I can see the arrows and I can see like the arrows.
No. The information is logic is carried by arrow. Information is carried by node. So I'm blocking the node means that I take that information out. How I take it out mathematically, I'm basically showing you take the information out by framing the problem. This is the part, what I'm saying is, I prefer you guys learn first is, would you agree with me? Red is a framing problem. You frame the problem differently and suddenly, I think, here, when I say conditionally independent or conditionally dependent with 3 nodes, okay? I don't really care, but you know for sure. Can I make something independent becomes not independent? I can make 2 things originally independent, but suddenly by framing and I can make them dependent. Is that possible? That's what happened here, right? And also, previous example, can I make something originally dependent, but if I frame a subset, I can make them conditionally independent. Is that possible? Yeah, so that's all you care about is that how can I frame their questions? But that's mathematically, when I frame the question, I'm building this probability statement. But that probability statement really relate to no, I don't let you pass, hey, all the information about the previous probability is carried by me. You want to know anything? Ask me. You don't need to ask previous one. Okay? And that is how this is done. Okay? And what is the example here? Minimum set for A and B. Here's A and here's B. Okay? Now, for this example, who want to volunteer? If I only block C, here, let me do it. If I only block C, can the 2 blue dots still share information? Yeah? Because they have what? Common descendant, right? Right? So this could be smoking, this could be toxic environment, but here are a lot of, vomiting, who knows what kind of symptoms are associated with it. So blocking this guy is not enough, agree? And then you can say that, how about just block this guy, right?
But you still have to block F for A and B not to be.
What?
You have block F and only E would be available.
Well, you still have communications going on here for the outcome.
Right.
Yeah, so what I'm saying is that this is, you guys already have the answer. I just need you to play the game yourself and then figure out, hey, let me add a little bit, and let me add a little bit. Can I, make that Markovian blanket happen and said that everything's need to be carried by my ancestor or my parent. I don't need to ask any further. Okay? And next. So on the Markov blanket problem, all you need to do is do the same things. Basically, first, identify a variable. Okay? And then figure out that how many things that I need in order to block the whole things. Okay? And finally, this problem, okay? This problem relates to what he asked me last time. Evidence is collected in J, right? And evidence is connected by J. So something happened here. If okay, something happened here. Do you think A probably could be responsible?
Yes.
Right? Could G be responsible? Yes. And could C be responsible? Maybe not. But what is the really troublesome part is that if, okay, here's the part that you need to know is that I got common influence from B and C, right? Agree? So in other words is that if something happened in I, could be from B, could be from C, right? And so now if I want to say that, I don't want this guy to get involved, just by A or C are not connected. Well, what I'm trying to say is this. A and C, okay, I need to disassociate them and say that they got nothing to do with each other. Okay? Who is the troublemaker I need to control? Everybody would agree with her? Because here is another root cause. And this root cause can bring things this way, can bring things this way. So here, if I see something in I, it could be from B, could be from C. If I see something in J, could be from A, could be from B. So B could make trouble here, B could make trouble here. So if I want to separate A and C, I need to get rid of the root cause from B. Okay? So what is the homework I'm looking for? Just build a block or shape or cloud, call it whatever, and say that, hey, let me, if you can say, let me put one in, is that good enough? I need to grow a little bit. Aha, now I can separate them. Then you understand how the answer is done. And for those of you come to me and say that, could you be my advisor for my capstone projects or whatever? Two things, right? You should take my class. You're not in my reliability class, and you didn't take my DOE, and at least now you have 2 hours of my lectures, right? And show me that you can use this to build, you can fake a problem properly this way. Then I know that you understand how probability, conditional, independent, dependent, and graph are associated. Then when you say, I have this wonderful data from this sponsor, I know you can do something about it, not by plug them into some software I never heard of. And you can do something very fundamental, okay? I would tell you this, okay? I worked for airlines before, I worked for insurance company before. A lot of time, if my boss sent me to an airport or somewhere, sometimes I don't walk in with SAS, with some software to tell people, here are my magic software or equations. Guess what's the most common tool I use to deal with the customer or my sponsor? What kind of software I usually use? Huh? Excel, spreadsheet, exactly. I'm going in, I just do some counts, say, okay, show me your data. And I try to explain stuff that way. If they can see it and they trust you, then you're coming back and say, I'm going to use R, I'm going to use Python. That makes sense. But if you going in and said that because you got a graduate school degree and then you just suddenly throw them a bunch of graphical output, you don't have the credibility to convince them. You need to first show them you can very quickly turn a real world problem into something simple. So your homework is turn them into something simple. And if you think you want to do more, do it. Maybe you don't do every one of them, but at least take a couple this way. I have something independent. If I frame this way, then some of the BN software, you can download for free. What's in there, you can see. It's just a bunch of bar chart. And the bar chart is based on, 40 out of 100, 30 out of 100. Join is 12 out of 100. They just write this in their software. So if you can do that in Excel, that's the best thing. Okay. So I hope this helped you visualize what I'm really looking for the homework. I'm not trying to give you a hard time, but since you got involved with this, ask yourself, what can I block the information Markovian wise? Is all the information need to be carried? If I hold this no, everything's all in. No need to ask any further. Okay, that is the homework due on Sunday. Shouldn't be too hard. I won't mind you guys discuss once a while. Try to figure out, hey, how come I didn't get the 7-1? But try at the end, do it yourself. This stuff you learn, it's like riding bicycle, is yours. Okay.